Hello and welcome to CIS 4510. In this session we will continue talking about the task analysis part of the project management, and we talked about the work breakdown structure. Now we are going to talk about the network diagram, and this is the second part of task analysis. So the project network diagram is a pictorial representation of the sequence in which the project work can be done. And for that we need the tasks, we need the task duration, we need the earliest time to start a task, the earliest expected completion date for the project or for the task, and the sequence of activities for these tasks. So the advantages of the project network diagram, that it assists in the planning process, where we know exactly which comes first and which one is critical and need to be done immediately. So based on that, we plan our project and we create a schedule to be in a sequence of implementation and execution for the different activities. In the implementation process, it assists us in specifying the date that we need to release, for example, a software for the customers to review and provide us with a feedback. Also, it can control the project execution. It can assist in the monitoring process. With the monitoring and control, that's a tool for the project manager to better control the schedule and monitor the different activities within the project to make sure that they are done within time and within budget. The network diagrams could be in two different ways, or could be built differently in two different methods. Either task on arrow or activity on arrow. This is how we call it, or we create or we use the task on node, and that will give me more information when it's on the node, because I will know that this activity will be done at that time, and I will know the start time, the finish time, and I will know which task has a lag or it's critical for me to finish before. And this is actually also called the precedence diagramming method, either PDM or AON method. To compare the activity on node and the activity on the arrow, we can see that it's easier to know exactly which one comes before. It's easier to follow up with the activities, and whether we do it this way or that way, we know how, if we have two different activities needed, like this one, A and B, this will lead to C. But if I have one activity that will lead to two activities, then this is the way to do it. Now look at the activity on node, and we have here three nodes that represent the task, while here I have to add a fourth node to make sure that I'm capturing the arrows that's going to the different activities, because the activity is on the arrow, is not on the node, and that's different, the difference between the activity on node and the activity on arrow. So we'll concentrate on the PDM method or activity on node, and we are going to create the work breakdown structure for our project. So we take the activities, and every activity in the work breakdown structure has a task node. We need to define the time estimate for the duration for the task. We need also to know the earliest start and the earliest finish to that one, and the late start and late finish, so we can define if there is a slack time that will be given to me or not. We can also add an ID for the task in case that some of the tasks will be described or will have a long name. So instead of using the long name, we can use the IDs to define which task am I talking about. Then we can determine the sequence of tasks, which one comes first. Every task has at least one predecessor and at least one successor, except the start and the end, of course. You can start, or you can put a dummy node at the beginning and say start, and a dummy node at the end and say end. So you will make sure that you have a start and an end. It could be zero duration for each one of these nodes, but it's just an assistant for you to assist you in knowing when the project started and when ended. Using the predecessors or the precedence diagramming method to identify the type of dependency, we will know finish to start, finish to finish, start to start, and start to finish. So when we say first finish to start, so when A finishes, B may start. When we say finish to finish, then when A finishes, B may finish. That means already we started with B during the execution of A. We started at a certain point with B, but it will not be able to finish. We cannot finish B until we finish A first. Start to start, when A starts, B may start at any time, at any point, so it's not related to the finish of A. We can start at any point. Start to finish means when A starts, B may finish at any time. We need also to choose the proper dependencies for the different activities. So we need to identify the predecessors to the task. We need to determine whether the start or finish of the predecessor controls the scheduling of the successor. Does it affect the task after that, or it doesn't? If it doesn't, then what do we need to do to start the second task, and so on. We need to determine whether the predecessor triggers the start or finish of the successor. We need to further define the task relationships, identify whether the dependency uses lead time or lag time. In addition, we need to look at the constraints. We have technical constraints that might affect the task, and they need to be identified. It needs to be added to the task. They can define the start and the finish of the task. We need also to manage the constraints, such as meeting the competitive pressure or get things done before a major event like holiday or conference or etc. For example, if we are trying to finish a website before Christmas, then I need to make sure that this constraint is being added to the tasks to make sure that it's been done before the Christmas holiday, and so on. We have to look at inter-project constraints, such as the need for a related project to finish their side of an interface before ours can start or can be fully tested. And that happens, again, in IT a lot, because if the server is not done, you cannot test the network to make sure that the network is working with the server. Maybe the wiring is okay, maybe there is a connection, but you need also to make sure that the interface of the network is working with the interface of the server client part of the company. And each project depends on the other. That's why we say inter-project constraints. It's two different projects, maybe they are two different projects, but at the same time I have to make sure that once they are done, they talk to each other and they work with each other. Also, we have date constraints that need to be taken into consideration. where a specific event guides an activity, such as needing a task done no earlier than or no later than or a specific day. All these are constraints that we need to look at and include when we are building our network diagram. The lag variability, it can be used to specify the delay between tasks or events. We might have some kind of a lag time in an activity. It can be positive or negative. It can be international. Also, it creates some constraints on the project activities. The lag is the time allowable for us to delay certain activity execution. So, for example, if I have a lag time of 2 days for an activity that is 4 days duration, then I have 6 days in total. So, although I have 6 days, but the task duration or the task can be finished in 4 days. That means, if instead of starting from day 1, I can start from day 2 or day 3, that will be fine, because still I can add, after the second day, I can add still 4 days for duration, and I will get 6 days. After 6 days, it will be critical. I will not be able to pass that time, and it might affect project execution or project progress. So I have to make sure that I'm within the lag time that's given to me to finish that activity. We can compute the project duration, the total duration for the project from beginning to end by doing either a forward pass or a backward pass that will give me the exact duration for the project. Usually we do a forward pass, it will give me the duration, and then I will go backward just to verify or make sure that what I calculated is correct. So it's better to do both forward pass and backward pass. During that time, like we said, some of the activities are very critical to be done within time. Some of them has lag, and you can delay them. You can do whatever you want with them within the lag constraint. But others don't have any lag. They have zero lag, and they need to be done in time. So those kind of activities are called critical activities. And those critical activities might affect the project execution. They might affect the completion date, and that's why I need to make sure that I'm executing these within the given period of time, or giving duration for that activity. Those critical activities, if I follow them, they will finish the project within time, and that's why we call them on a critical path. They represent for me a critical path. So the critical path is the list of critical activities that will affect the project duration or the project execution or completion date. And we need to finish these first, or we need to make sure that they are done in time. If you have any questions for the network diagram, for work breakdown structure, or for any other questions, just email it to me. I will be more than glad to assist you in that. Thank you, and have a great day.